Hey everyone, welcome back to Science Layer. Today we're going to be talking about Le Chatelier's principle. In this lesson, we're just going to be describing how a dynamic equilibrium changes to respond to anything that causes an imbalance in the equilibrium system. Le Chatelier's principle just describes how equilibriums respond to changes, and some things that you should keep in mind while we're going through this is what a shift is. A shift to the right means that the concentrations of the products will increase, and a shift to the left means that the concentration of the reactants will increase. We'll further elaborate this and you'll get to visualize it better once you see it in action. So let's begin by talking about the causes of equilibrium shifts. This yellow highlighted formula here is just a general formula in which A and B are the reactants and C and D are the products. The equilibrium sign, of course, means that this is an equilibrium system. Square brackets means that we are talking about the concentration of something. So let's say we are increasing the concentration of compound A. Well, this is no longer at equilibrium because something has changed. And so to counteract this change, the dynamic equilibrium is going to shift towards the products, because you can think of it as the products having a deficit in concentration. And so to increase the concentration of the products to balance with the concentration of the reactants, the equilibrium is going to shift to the products or shift to the right, which makes the products' concentration increase. Now, if you want to see it in words, this is how it looks. Just some things about this statement. Increasing the concentration of the reactants shifts the equilibrium to the right or the products. And this can be also stated as the equilibrium favoring the right / the products. You can see this in any way, so just be sure to know that it means the same thing, that when the equilibrium shifts to the right, it is going to cause the product's concentration to increase. Even though initially we had the reactants increase in concentration, that increase causes the equilibrium to shift to the opposite side, which creates the increase in product concentration. That way the equilibrium can be balanced once again. Now let's look at the second scenario involving reactants. Here we have, again, our compound A, decreasing in concentration. Now we are seeing a shift towards the reactants because the equilibrium is not balanced anymore, and since the reactants are decreasing, the equilibrium is going to want to shift to the side that's losing something to make it increase once again. So you'll see that the equilibrium shift will cause the reactants to increase. Even though they were initially decreasing, as soon as that equilibrium shifts towards the reactants, it's going to cause the reactants to increase once again. A trend you might have noticed from these two examples already is that when an equilibrium shifts towards a side, whichever side that it shifts towards, that side is going to increase in concentration. Written in words, it looks like this. Once again, this can also be written as the equilibrium is favoring the left or favoring the reactants just because it increases its concentration. So be aware that you might see it in different ways, but it is asking or saying the same thing. Now that we've seen the two causes and effects of an equilibrium shift that relates to the increase or decrease of reactant concentrations, let's take a look at what happens when we increase and decrease product concentrations. Here, our compound D is being increased in concentration. As you may have seen above, when we increase the concentration here, it causes an imbalance, of course, and so the equilibrium is going to shift towards the opposite side, which is the left side, or the reactant side in this case, to regain its balance. So by increasing the concentration of the products, the equilibrium shifts towards the reactants, which in return increases the concentration of the reactants. And all of this is just to create that equilibrium once again. Even though initially we had the products increasing in concentration, that increase causes the equilibrium to shift towards the opposite side, which in return increases the concentration of the reactants. And I'm just reiterating this just to get you guys to understand that wherever the equilibrium shifts towards, that side is going to increase. And you need to know when the equilibrium shifts towards the products or the reactants. In this case, we are shifting towards the reactants because the products had increased. Now, what's going to happen if we decrease the products? Well, once again, you can think of it as a deficit. When you lose something, you want to replace it or you want to fill it up with something else. Let's say you dropped your glass of water, all of your water is gone, so now you need to refill your cup. That way, we can think of this in that situation, and the products are decreasing, so you're going to have a shift towards the products to try to balance that equilibrium once again. By shifting towards the products, we know that the products are going to increase. As we saw in the previous examples, whenever the equilibrium shifts towards one side, that side is going to increase in concentration. Written in words, it looks like this. Once again, this can be written as decreasing the products causes the equilibrium to favor the right side or favor the products. And also, by saying right or left, we are literally just mentioning the side of the system. So the reactants are considered to be the left side because they are towards the left, and the products are considered to be the right side because in the forward reaction, when we read it in this way, we read it from left to right. Now we've discussed the various effects, and there are 4 of them: an increase in concentration of reactants, a decrease in concentration of reactants, an increase in product concentrations, and a decrease in product concentrations. All of these causes have effects, and the effect of these causes can be put into 2 groups. The effect of an equilibrium shifting towards the left is the concentrations of the reactants will increase, because remember, reactants are towards the left side of our system. So whenever we are shifting to the left, we are increasing the concentration of our reactants, left side, and the concentration of our products is decreasing. Now, over in this section back here, we said that a shift to the left, or the reactants, causes the reactants to increase, but we didn't mention that the products are actually decreasing. Well, they are, and you'll get to actually visualize this when you look at equilibrium graphs. I'll be doing that in a separate video just to make sure that you guys don't lose attention on this. So right now, let's just stick to knowing that this is the effect when shifting to the left. And the effect of shifting to the right is that the product concentration will increase. So now that we're looking at the product, we are also looking at the right side. So shifting towards the right side will increase the right side. This side will increase, and the concentrations of the reactants will decrease. Once again, in the 4 causes that we discussed earlier, we did not discuss the decrease of one or the other. We only discussed which one increases when the shift occurs. But you will see how they decrease when we explore graphs. One final note is very important, that whichever side the equilibrium shifts to, it increases the concentration of whatever is there. So even if that same side initially decreased in concentration, when the equilibrium shifts towards that side, it'll cause it to increase and regain a balanced system. Example of this can be the decreasing reactant situation or decreasing product situation, and it is important to differentiate the causes and the effects because you can get different questions asking about the cause or the effect, and you're going to need to figure out which one you're talking about. I hope this lesson on Le Chatelier's principle made sense, and if it did, please let me know, and if it didn't, please let me know so I can improve the way I teach. Thank you all so much for watching. I hope this was beneficial to you. See y'all later. Have fun in chem.